As we get into this, part of why people have trouble with integrals here is because questions that look very similar can have quite different answers. Okay, all of these questions look very similar. Well, this one has a square root, but it's, x squared plus 1 on the bottom. Depending on what else is there, whether there's, an x on the top, not an x on the top, square root, and these things, it can come out quite different. If you are trying to integrate this, you could do this one with substitution. If you made, what would you try making u into here? X squared plus 1. That's a good choice, right? When you're doing substitution, if you try something that doesn't work, you could just change and try something else. 2x dx. You happen to have 2x dx there, so it's going to work well, right? So you're going to have integral of 1 over u du, and you can finish that one, right? It's going to involve natural logarithms. Natural logarithm, absolute value of u, and x squared plus 1, right? If it's the fact that this has this power of 2, like I kind of alluded to before, then it's going to look quite different, right? If you did that one, would you use natural logarithms? You can't, right? You can still use the same thing here, right? And you can make this integral of 1 over, this is going to be u squared now, du, right? You have that, and this is this. What's that going to turn out to be? It's u to the negative 2. So what's it going to be? Well, you're going to make this new power here first, negative 1. And then negative 1 out there, right? Plus a constant. So negative, this is 1 over u. So this is negative 1 over x squared plus 1. So this looks a lot different than this, right? Sometimes it's going to involve natural logarithm. It's going to involve natural logarithm when it's 1 over something to the power of 1, right? If it's some other power, it's different. If there's a square root involved here, it's probably going to end up different again. The last one here, I actually intended that this x wouldn't be here, to be honest with you. I copied and pasted, but then forgot, I think. No, you know what? No, I remember. I don't know why I put this one as it's exactly the same as the first one with a 2 in it. That doesn't change it. This is the point here. What if that x wasn't there? What could you do? If you made u into x squared plus 1, would substitution work? You can deal with the 2 being back there. Now I remember why I put it in there, because the 2, it's okay if the 2 is not there for this 2x dx. Is it okay if the x is not there? It doesn't work by substitution then, because you have to have you have to be able to replace x dx here, because you can always make this a half du equals x dx, but you can't go without that x there in the thing. If the x isn't there, you can't do this the same way, and this is suddenly where it becomes troubling, because this is actually the derivative of something that you know. What is it the derivative of? If you flip the page, you can find out. Arctan, inverse trig functions, right? Remember that before, when you did derivatives of arctangent, you found that it was 1 over x squared plus 1. We went through a long procedure for that, and you didn't like it because there was no trig function in the actual derivative. So then if we turn that around here, what's the integral of 1 over x squared plus 1? Arctan. Nope. All right. If it's a u, yep, because you've already dealt with that thing. I mean, that doesn't come up very often, and it's hard to recognize, because it was okay when you saw arctan, which didn't come up very much. You said, oh, arctan, it was one of those ones where it was different, and you probably could remember this. This people find hard just because it doesn't come up that often, and when you see this, it doesn't trigger in memory that it's supposed to be arctangent. it's difficult because if you go back up here, if there's an x on the top of that x squared plus 1, then it's going to be something that looks like this. If there's no x there, like down here, it's going to be arctangent. That's the concept is still the same, how you go through and do substitution with everything. It's just that you have to be able to kind of recognize and think about that be looking out for that. I'm not saying that you have to go and do all the questions in this section right now, but I wanted to kind of point that out to you so that you could go ahead to those. Arc sine, do you remember what it is? What's the derivative of arc sine? Arc cosine is just that with a negative. So then the integral of this is arc sine. All right? I think you have enough to get going here. There's one other thing I want to show you later, but we can leave that till... I don't know why this is not moving here. It's actually in the other section, but that's okay. There's something I put a little note next to that I want to show you, but we can do that after spring break. All right?